Here we are discussing a question from the chapter Complex Numbers. Question is, represent the complex number 1 minus 3i upon 1 plus 2i in the polar form. Okay, this form is in Cartesian form and we have to write this form in polar form. So, for finding the complex number in polar form, first of all, we will write this expression in standard form of the complex number. You know, z is equal to x plus iy. This is called standard form of the complex number. So first of all, we'll simplify it and convert it into standard form. So let us see solution here. Let us suppose that the complex number z is 1 minus 3i upon 1 plus 2i, and this is equal to, here we have to multiply numerator and denominator by the conjugate of the denominator. Conjugate of denominator will be 1 minus 2i. We have to change the sign of imaginary part. So conjugate is 1 minus 2i. So this is equal to 1 minus 3i upon 1 plus 2i into 1 minus 2i upon 1 minus 2i. Let us simplify it. Here denominator is in the form of a plus b into a minus b, that is a square minus b square. And in numerator 1 into this much is 1 minus 2i, and minus 3i into this much is minus 3i into 1 is minus 3i, minus minus plus I into I is I square, that is minus, and 3 2 just 6, so minus 6. And this is equal to minus 5 minus 5i upon 1 I square is minus 1. Okay, I square is minus 1 and this is 4. So minus minus plus 4. Here we can take 5 common. Minus 1 minus I upon 5. 5 is cancel out. So we are getting z is equal to minus 1 minus I. Let us write relation number 1. And in polar form, let the complex number z be r cos theta plus I sin theta, relation number 2. Now here we have to find out the value of r and theta, and after putting the values of r and theta, we will get the required result. We will get the complex number in polar form. So now we will compare these two relations 1 and 2. Comparing relation number 2 and 1. So here real part is r cos theta, this is equal to minus 1. Let us write this relation number 3, and r sin theta, this is equal to also minus 1. Minus 1 is relation number 4. For finding the value of r, we will square and add these two relations. So squaring and adding relation number 3 and 4. R square cos square theta plus r square sin square theta, left hand side r square will be common, so r square times of cos square theta plus sin square theta is equal to, in right side, minus 1 square plus minus 1 square, that is 1 plus 1, that is 2. Cos square theta plus sin square theta is equal to 1. Okay, so we are getting here r square is equal to 2, and therefore r is equal to square root of 2. So here we are getting value of r. Now we have to find out value of theta, and for finding the value of theta, we will divide relation number 4 by relation number 3. Okay, so dividing relation number 4 by Relation number 3. This is r sine theta in left hand side and this is r cos theta. So r of sine theta by r of cos theta is equal to minus 1 by minus 1. Minus 1 by minus 1. R will be cancelled out. So we are getting tan of theta is equal to 1. Okay. But you see that this is complex number having coordinates minus 1, minus 1. So this corresponding point will lie in third quadrant here. Here x coordinate is minus as well as y coordinate is minus. Okay. So theta is equal to pi plus pi by 4 and this is equal to pi by 4. Correct? So we are getting value of theta also here. This is 5 pi by 4. Therefore, in polar form, complex number z is equal to r cos theta plus I sin theta. R is root 2 into cos of theta. So cos of 5 pi by 4 plus I sine of 5 pi by 4. So this is the required answer. Complex number in polar form. Hope understood it. Very interesting questions. So remain in touch with this video. You'll see some more important questions and share this video with your friends also. Wish you all the best.